Suppose we want to compose the cosine function with the inverse cosine function. Let's look at the domain and the range, first of all, to see how the composition would work. So let's say that f of x is cosine of x, so that the inverse will be the inverse cosine. Okay, as it stands, the cosine function does not have an inverse, so we had to restrict the domain between 0 and pi, so that it would pass the horizontal line test. And then the range of cosine is just from -1 to 1. So then with the inverse, the domain and the range are going to flip-flop, so that the domain of the inverse becomes the range of f, which is from -1 to 1. And then the range would be the domain, which is from 0 to pi. So then doing the composition, let's do f with f inverse. Little substitution, so f of the inverse cosine. So then the inverse cosine is going to go inside of cosine. Since these are inverses, they would undo each other, giving us back x, as long as inverse cosine of x was defined to begin with. And that would be defined when x is in the domain of the inverse, which is -1 to 1. Okay, it can go the other way. F inverse composed with f. So f inverse composed with cosine. So that cosine goes inside of the inverse cosine. These would undo each other, giving us back x, as long as cosine of x was defined according to our inverse. So the angle restriction on x was between 0 and pi. So let's do a few examples with composition, making sure the domain is satisfied. So let's say we have cosine of inverse cosine of, let's say, 0.7. Since these are inverses, it would be really nice if they just undid each other, giving me back 0.7. So I'm going to put a question mark up here first, because I want to make sure that the domain is satisfied. So 0.7 is on the inverse cosine, so I have to make sure the domain of inverse cosine is satisfied, which is the same thing as the range of cosine, which is from -1 to 1. 0.7 is less than 1, so this is true. So they do undo each other, giving us back 0.7. Okay, let's say we have the cosine of inverse cosine of let's say pi/2. Again, this would be really nice if they just undo each other to give us back -pi/2. But we need to check our domain restriction on inverse cosine, which again is just the range of cosine, which is -1 to 1. So I need to check that -pi/2 is between -1 and 1. Well, pi is about 3.14, so 2 goes into 3 more than once. So this is not going to be true. This is going to be less than -1. So that's not true. So this means that the inverse cosine of -pi/2 does not even exist. So the composition certainly does not exist. Okay, let's go with an inverse first. So let me do inverse cosine of cosine of, let's say, pi/5. Again, this would be really nice if they just undo to give me back the input of pi/5. So this is going to be true if the angle restriction, because cosine is inside this time, the angle restriction is satisfied, which is between 0 and pi. And it is. 1/5 of a pi is certainly less than pi. So these undo each other, giving me back pi/5. Let's look at one more. It's going to be a little bit trickier. Let's do inverse cosine of the cosine of 9pi/8. Again, this would be really nice if they just undo. So let me put a question mark for now. The angle restriction on cosine is between 0 and pi. 9pi/8 is not satisfied because 8 goes into 9 more than once, so this is going to be more than pi. However, the cosine of 9 pi over 8 is still defined. So what we're going to do is a little clever maneuver and move the angle into the proper quadrant. So let me start by drawing where the angle is. Again, 8 goes into 9 a little more than once, so it's in the third quadrant somewhere. So what I'm going to do is move this angle, but I'm going to keep the cosine the same. So I'm going to keep the cosine the same. In other words, I'm going to keep the x-coordinates the same. Okay, so I'm going to redraw this angle so that x stays the same. Keep in mind, inverse cosine, we have to look at either the first or second quadrant because it's between 0 and pi. So you can see it's going to be in the second quadrant. So if we take a point on the terminal side of the original angle, we would have negative x, negative y. And then taking a point on the terminal side of the other angle, you'll notice that the x is still the same. So that means that the cosine is still going to be the same. So now I need to figure out what is that angle. So let me figure out first of all the reference angle of the original angle. So 9 pi over 8 is 1 1/8 pi. So I go 1 full pi and then another 1/8 of a pi. So you can see that that matches with the other angle. But reading the angle from standard position, however, if that's 1 pi over 8, then we're left with 7 pi over 8. So hopefully you can see that the cosine of 9 pi over 8 is the exact same thing as cosine of 7 pi over 8. The x-coordinates are the same. So doing a little substitution here, I would have the inverse cosine. Instead of cosine of 9 pi over 8, I'm going to write cosine of 7 pi over 8, which is in the restriction between 0 and pi. So these undo each other, giving me my answer.